In the last video, I created an interface called Operation, which had a single abstract method I called Operate. Operate was the functional method for that interface. I made it a method with a generic type, taking two values and returning a result, all required to be the same type. Although this was a good way to understand how to create a functional interface, it turns out this interface is almost an exact copy of another interface that Java provides for us. Java provides a library of functional interfaces in the java.util.function package. We've looked at one already when I demonstrated the forEach method, which had an argument for a type that implemented the consumer interface. I'll look at another of these interfaces now, the binary operator in code. I'm going to change my calculator method. Instead of my own interface, which I called Operation, I'm going to make the first parameter a binary operator. This gives me an error on the first statement where I'm executing Operate, which was the functional method name on my own interface. The functional method name on the binary operator is apply, so I'll change Operate to apply. With those two changes, my code compiles, and if I run it, I get the exact same results. I didn't really need to create this operation interface at all. As it turns out, a lot can be accomplished with just a few different types of interfaces, and Java gives us a library of these. Java's libraries also use these interfaces extensively so that we can leverage lambda expressions in many methods, the forEach method on the array list being just one example. It's a good idea to know the four basic types of functional interfaces in the java.util.function package. There are over 40 interfaces in this package, but I don't want you to feel overwhelmed by that. This slide shows the four categories, with the simplest method shown. These can all be categorized as one of the following types: consumer, function, predicate, or supplier. Consumer interfaces are used to execute statements, but don't pass any data back. They take one or two arguments of various types, but return no value. Function interfaces are used to perform an operation and return a result. These take one or two arguments of various types and return the result of some formula or calculation, much like the operation interface I created in the last video. Predicate interfaces are used to test a condition and take one or two arguments, again of various types, and always returns a Boolean result. Supplier interfaces are different because they take no arguments, but return an object, which can be various types. Supplier interfaces are used to return an instance of something. A factory method might be a good lambda expression for this type of interface. On this slide, I'm showing the two most common consumer interfaces and the functional method on each. The consumer interface takes one argument of any type. The by-consumer interface takes two arguments of two different types. This slide shows an example consumer lambda expression. It takes one argument and executes a single statement. No result is returned. You saw an example of the single argument consumer using the forEach method on a list of strings to print out each string. Getting back to the code, I want to set up an example that uses both consumer and by-consumer. I'll start with a list of arrays, both having two double values. These sets of values are going to represent the latitude and longitude locations of 3 points on the Mississippi River. You may remember that I used these coordinates in a previous video. I'll create a local variable, coords, and simplifying the type declaration by letting Java infer it with var. I'm using arrays dot as list. And add some hard-coded double arrays containing the coordinate data. That gives me a list of double arrays. I next want to print that out, and I'll use the forEach method with println. This time I'll pass it arrays.toString with s as its argument. Remember, the forEach method is really using an enhanced for loop, iterating over each element in my coordinates list. That means the s variable here is really an array of double because my list is made up of arrays of doubles. I use arrays.toString to print out the elements in my array and pass that to println. I showed you this method before, except I just printed strings previously, and here I am printing arrays. I'll run that now. I get my coordinates printed out, one for each line. But what if I want to print this out in a different way? I'll do this now, demonstrating a by-consumer functional interface in the process. My method will again be a generic method with no return type, void, and called process point. I'll pass T1 and T2. Both will have the generic type T, and I'll also pass an instance of the by-consumer interface that takes two type arguments. I'll make both of these t as well and name the argument consumer. Then I'll simply execute consumer.accept, passing it method arguments t1 and t2. A by consumer takes two arguments, and in this code, I'm saying they'll be the same type by using t, t in the angle brackets. This executes code that doesn't return a value or whose return value can be ignored. Before I call this, another thing I want to show you is that a lambda expression can be assigned to a local variable. I'll do that next in the main method. I'll set up a variable with a reference type by consumer and the same type arguments, both double. I'll call that p1 and assign it a lambda expression. My lambda takes two parameters, so I'm calling those lat and long, and then I'm going to print out my coordinates in a nicely formatted way using the printf method. If I run this code, nothing additional is executed, even though I've declared the lambda expression here. Declaring a variable with a lambda expression isn't going to actually execute that expression. Instead, I need to manually call the functional method on that variable or pass that variable to a method that does the same thing. I'll pass this variable by calling my process point method. First, I'll create a local variable called firstPoint and assign it the first element in the coordinates list by calling get passing 0. This gives me the first coordinate pair for the river location data. Then I'll call processPoint, passing the first and second doubles in the first point array, as well as the variable p1, my lambda expression variable. Let's see what that gives us. You can see the first point gets printed out using that lambda expression's formatted string. Next, I'll print all the points and use the for each method to do it. First, I'll print a separator line. Then I'll call for each on my coordinates list and pass it a new lambda. We know that it takes a single parameter, and in turn this will call the process point method, passing the first and second elements in the array and also the p1 variable I set up earlier. Now if I run this, I get all three of my points printed out using my custom formatting. That's pretty nice. I could replace p1 in this expression on line 50 with the actual lambda expression that I assigned to that variable. Let me show you that. First, I'll copy and paste that last statement, adding a new line after the first two arguments. Then I'll go up to line 43 where I've created the p1 local variable and copy everything after p1 equals on this line and the next, except the ending semicolon. I'll go down and replace p1 in the last statement with that. Here you can see I've really got nested lambda expressions, which may not have been obvious when I was using the local variable p1 that contained a lambda expression. Now this code is getting a bit ugly really for anyone trying to read it, but it works the same. I will run it just to confirm that. I get my three coordinates printed yet again. Okay, so that covered the consumer and by consumer interfaces. In addition to these two, there are various special variations of other consumer category type interfaces. For example, some let you pass a primitive as an argument. I won't cover all the variations of all these built-in interfaces here, because that would take a long time and wouldn't really add a lot of value. Many are for very specific cases and not used that often, but as the course progresses, you'll be seeing me use them where appropriate. Moving on from the consumer, I now want to look at the predicate interface, which is the second category of interfaces in this package. The predicate interfaces take one or two arguments and always returns a Boolean value. They are used to test a condition, and if the condition is true, to perform an operation. In this example, the expression takes a string and tests if it's equal to the literal text hello, ignoring case. It returns either true or false. Getting back to our code, I want to review another method on the list interface that I haven't yet covered. I've left it to here in the course because you needed to understand some basics about lambdas first. This is a method called removeIf, which takes a predicate type as an argument. I want to use my list of NATO alphabet strings to demonstrate this method, so I'll invoke removeIf on list and pass a lambda expression. The lambda has one parameter, like a consumer, and in this case it will be inferred to be a string, because my list is made up of strings. I'll follow that statement with a for each call to print my list elements. Can you guess what the results will be? By looking at this lambda expression. I'm calling removeIf and passing it an expression that says s equals the literal string bravo, ignoring the case. I'll run it so we can see the result. you can see that I've successfully removed Bravo from my list. This occurred because if the lambda expression that gets passed to removeIf evaluates to true for any element in the list, it gets removed. That's pretty slick. This method removes any elements that match that predicate code, meaning it can remove 0 to all elements in the list, depending on the expression used. I'll add a couple more elements to this list, just some strings starting with E, so Echo, Easy, and Ernest. And I'll print my list out. I'll run that. You can see these strings printed out. Next, I want to use this same removeIf method, but this time to remove any string that starts with the letters EA. I'll first add a line separator to make the output easier to read. Then I'll invoke list.removeIf with a lambda that uses the string method, starts with passing that a string value of EA. And again, I'll print the elements in the list out. I'll run this now. You can see that both Easy and Ernest were removed from the list with this single line of code. Let's see what the removeIf method is really doing under the covers. I'll use Control-click on that method name, and that will bring up the collection interface class at the default method removeIf. The method argument is of type predicate and called filter. It uses an iterator type to loop through all the elements, and that calls the test method on the filter instance to determine if an element should be removed. This is a good reminder that an iterator allows the removal of an element being iterated over, as this code demonstrates, and which I covered in an earlier video. You'll learn more and be able to review many of the concepts I've covered in real-world scenarios if you make it a practice to see how Java implements its own code, like I am doing here. This ability to see Java's source code is a great learning tool. You can imagine how many ways you can customize expressions you pass. This method, by using a functional predicate interface, gives us very easy, customizable ways to remove elements from a list. Those are real-world usages of both the consumer and predicate functional interfaces. In the next video, I'll cover the last two category types, the function and the supplier interfaces, and their different variations. See you in the next video.